Questions 2. A point charge Q1 experiences a force F1 equals to 8 at the unit vector x minus 8 at the unit vector y, and then plus 4 at the unit vector z newtons. Due to another point charge Q2 located at 3 minus 3 minus 2 meters, if the point charge Q1 is 3 microcoulombs and is located at the vector positions 1 minus 1 minus 3 meters, determines the magnitude of the point charge Q2. Okay, so again we can draw out our scenario. So we have Q1 at the vector positions of 1 minus 1 minus 3. Then we have our Q2 at 3 minus 3 minus 2. Again, reference to our origins, 0. So we call this R1, R2. Similar to question 1, we can write down the vector between 1 and 2. So our vector between 1 and 2, we call that our vector R. And again, draw it by conventions. The vector force F2 is in the same direction as our vector R, and our force F1 is in the opposite direction of F2. Okay, information given is that the force F1 is equals to 8 in the x directions minus 8 in the y directions, and then 4 in the z directions, newtons. Other information given is that Q1 is 300 microcoulombs, and you're asked to find the charge Q2. So we can go ahead, write down our Coulomb's law. F2 is equals to minus F1 is equals to Q1 Q2 over 4 pi epsilon naught magnitude R squared times our unit vector R. So this leads us back to working out the vector R and the unit vector R. Okay, I'll continue up here. So our vector R is equals to our vector R2 minus our vector R1, and that's equals to 3 minus 3 minus 2 minus 1 minus 1 minus 3. This equals to 2 minus 2 1 meter. And then the unit vector of this, which is a vector R over the magnitude of our vector R, four plus 4 plus 1 just give us 0.667. Let me write it down at the bottom. (0.667) minus 0.667, 0.333. Okay, so we got our vector r, we got our unit vector. So we know our vector r, we know our unit vector r, and we know the magnitude of vector r, and we know the charge, so we can find what is Q2. So our force F1 will be equals to minus, okay, so our F2 is equals to Q1, Q2 over 4 pi epsilon naught, and so forth. So our F1 will be minus of F2, so it will be minus Q1, Q2 over 4 pi epsilon naught r squared times our vector, unit vector r. So F1 is 8 minus 8, (4). Q1 is 300 microcoulombs. Q2 is the one that we want to find, over 4 pi. Epsilon naught is 8.854 times 10 to the minus 12. Then our r is 4 plus 4 plus 1, that will be 9. Square root of 9 is 3. So there will be 3 squared. And our unit vector, write it up here, times 0.667 minus 0.667, 0.333. So if you put in all this value in your calculator and take Q2 as the subject, you'll find that every single point x, y, and z, Q2 will give you a value of minus 4.006, or just going to use minus 4 times 10 to the minus 5 coulombs. Okay, so that is the solutions to questions 2. So if you get x not the same value for y, or not the same value as z, then must be something wrong with your calculation. So all the x, y, and z components should give you the same answer for Q2 equals to 4 times 10, or minus 4 times 10 to the minus 5 coulombs. Okay, so that's the solutions to questions 2.